Not long ago, a team of astrophysicists at the Space Telescope Science Institute in Maryland in the nearest globular cluster 7,200 light-years from us, discovered a theoretical black hole that had never been exist, and present this to the Royal Astronomical Society. In the 20th century, Einstein published his one-sided theory of relativity. He discovered that the gravity is caused by bending of spacetime by the mass of an object. Based on this, the gravitational equation is created. According to the gravitational equation, the greater the mass of an object, the higher the density, and the greater curvature of spacetime. It's Schwarzschild, who looked at these gravitational equations, that when the density and mass of suspitons become very large, spacetime is so distorted that not even light can escape. It was discovered and later called a black hole. Black holes were theoretically possible, but literally even light couldn't escape. Observation was difficult. Then, in 1990s, at the center of our galaxy, astronomers look around in Sagittarius, have find something very surprising. A myriad of stars were orbiting what is believed to be the center mass of our galaxy. But the problem was that there was nothing there. Even the speed of stars orbiting the center of the Milky Way were observed that there is nothing there. The mass of Sagittarius A is over 4 million times than the mass of the Sun. Even though there is an object with more than million times than the mass of the Sun, is not captured by the state-of-the-art telescope. This was the proof that it was a black hole, a celestial body that only existed in theory. And since the 1990s, many stellar mass black holes and supermassive black holes have been discovered. It was still a mystery how such supermassive black holes could have risen. Not long ago, a team of astrophysicists at the Space Telescope Science Institute in Maryland in the nearest globular cluster 7,200 light-years from us, discovered a theoretical black hole that had never been exist, and present this to the Royal Astronomical Society. According to a report published in the Journal of the Royal Astronomical Society, a theoretical intermediate mass black hole exists in the Messier 4 globular cluster. The black hole we know today is so-called stellar mass black hole by supernova explosion. Located at the center of large galaxies such as Milky Way and Andromeda Galaxy. Different hypotheses suggest that a stellar mass black hole created in a supernova explosion in the early universe. It absorbs a lot of matter and grows, and finally the mass becomes too large. It is an established theory that large galaxies such as our Milky Way were created by the accumulation of these processes. In fact, a black hole is a celestial body from which not even light can escape. At first glance, this sounds like a very reasonable idea, but there's actually a big problem with this. Stellar mass black holes that are several times the mass of the Sun continue to grow. If it becomes a supermassive black hole, it will become of more than 100,000 times, it will be between. That is, there must be so-called intermediate mass black hole with mass, because so many small black holes and supermassive black holes have been discovered so far. Surprisingly, no evidence of an intermediate mass black hole has been definitively proven. Even the definition of an intermediate mass black hole is 100 to 100,000 solar masses. It has a very wide range, and black holes belonging to this range of mass, a missing link, can be seen as so-called missing link. And because of the existence of this missing link, a stellar mass black hole grows. There are many scholars who dispute the hypothesis that supermassive black holes are. It's like the evolution from primates to Homo sapiens when there were few fossil finds in the past. It is odd that there are no intermediate black holes that develop into supermassive black holes. Of course, in the case of theory of evolution, all intermediate fossils have now been found. The evidence consistently supports the theory of evolution. There are no scholars who questions this. It is a problem that not a single black hole between 100 and 100,000 times has been found. Therefore, supermassive black holes do not grow from small black holes. However, stellar mass black holes can be identified through binaries. Supermassive black holes can be directly observed by observing the center of the galaxy. Intermediate mass are black holes in which even light cannot escape. In the first place, the hypothesis that observation was difficult and more dominant. And this time, the research team argued that an intermediate mass black holes that was difficult to observe in first place. The Messier 4, M4, globular cluster contains very many stars. T is an area that is densely packed with high density. The team used 12 years of data to record the allocation of the stars in the cluster. We studied how the stars around the center move. As a result, the research team discovered that the countless stars are orbiting something undetectable. It is a densely packed region.